Okay, we're going to have a look at some of the maths problems for today. We're going to start with question number 1. Millie and Ryan having a lovely conversation about some numbers. Fun times. So, what's my number? Is it under 20? Yes. Is it a multiple of 3? Yes. Is it a multiple of 5? Yes. Okay, so we're looking for a number that's a common multiple of 3 and 5 and under 20. Easiest way to do that is to find the common multiple of 3 and 5. Common multiple of 3 and 5 is 3 times 5 is 15, which is fairly straightforward for that. 15 is our number. They play the game again. Obviously really enjoyed it. Is it under 20? No. Is it under 25? Yes. Is it odd? Yes. Is it a prime number? Yes. So that means it is an odd number between 20 and 25, so it's 21. It's not that. It is 21 or 23. Okay, but it's also a prime number, which means it can't be 21 because 21 is in the 3 and 7 times table, it has 3 and 7 as factors, which means that 23 is our prime number between 21 and 25. Okay, question number 2 is after 5 squared. Should be really straightforward for that. Anything squared is multiplied by itself. 5 times 5 is 25. Question number 3. A number multiplied by itself gives the answer of 49. Okay, so what we're looking for here, multiplied by itself, that means that we are looking at a square number. Okay, we're looking for a number multiplied by itself. If that doesn't instantly jump out to you, just write out all of your square numbers. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. That gives us this answer here, which means that 7 times 7 is 49. Okay, there's always ways to work through those if they slip your mind at the time. So here are some digit cards. We have 7, 5, 2 and 1. I need to choose 2 cards each time to make the following 2-digit numbers. The first one is done for you, okay? And because I've got lots down here, I'm obviously going to be able to use them more than once. So a multiple of 9 is going to be on here. So I need to be looking at this, I need to be thinking, okay, well, how can I make a multiple of 9? The first one that would jump out to me would be 27, okay, which would be 3 times 9. We can, of course, do that the other way around and have the number 72, because that is also a multiple of 9. So either one of those can go into that one there. Okay, a square number. Okay, well, looking at those, I need to choose 2 of them, so it can't be 1 as a square number. So then I can either have 12, 21, that doesn't work. 15, 51 is not a square number. 17, 71 is not a square number. Okay, then I can look at this the other way. I could have 75 is not a square number. 72 is not a square number. 57 is not a square number. 52 is not a square number. But 25 is. Okay, oh, I've missed out my middle. 25 is a square number here. So this could be this one here. Sorry, 27, 72. A factor of 92. So that means a number that I can divide 90. Is it 92? 96. So I'm looking for a factor of 96, a number that I can divide 96 by. 96 jumps out to me as a number from my times tables. 96 is 8 times 12. Okay, so if I can make 12, I should be fine, and I can there. 1, 2, make myself 12, so that'll give me that factor of 96. If I couldn't have made the 12 there, I can then use this information of my 8 times 12 times table here and work out some factor pairs from that, and I could have backworked that in order to find an answer there. Okay, question number 5. Diagram for sorting numbers. I need to write the 3 numbers in the correct boxes. You may not need to use all of the boxes. Read the questions carefully. Okay, that helps us out here. So I've got 9, 17 and 20. So I can look at prime numbers and not prime numbers. I know that 20 is not going to be prime because the only prime number that's even is 2. So 20 is going to go straight into not prime and even. So that's a really straightforward one to do there. Okay. Now for the last two, I've got 9 and 17. So obviously both of them are not going to be prime because the only even prime number that I could have in that box would be 2, and I don't have 2, so I'm not going to have an even prime number, which tells me that this box here is going to remain empty, so don't put anything in there because I don't need it. So I'm looking for a not even prime number, and I'm looking for a not prime not even number. Okay, well fortunately both 9 and 17 are not even, which means that both of those are going to fit in those boxes nicely. And then one of them is prime and one of them is not. 9 is the same as 3 squared, so it's in a 3 times table. It has factors of 3, 1 and 9. And because it doesn't have 2 factors only, it means it's not prime, and because it's not prime, it's not even, it goes here. Okay, which means I'm left with 17. 17 should go in there because it's not even. Is it prime? Yes. So that's where those go. Question number 6 is 3 cubed, which is the same as 3 times 3 times 3. Work the first two out. 3 times 3 is 9, times 3, 27. Okie doke. So, here is a sorting diagram for numbers. Write a number less than 100 in each space. Okay, so I need a square number that's even, and I need a square number that's not even. So this first row here are going to be square numbers. Okay, so again I can just write out my square numbers here, and if I did that I would get myself ones that would fit those criteria. So square numbers, 1 times 1 is 1, 2 times 2 is 4. Okay, first two fit my criteria there, 4 and 1. Okay, and then I need an even number that's not a square number, and I need a not even number that's not a square number. So here, not even just means odd. Okay, I need an odd number that's not a square number. Okay, so, okay, 2, 3. Okay, I don't need to find large numbers. I know it says less than 100 up here, but I've used the first 4 numbers and I've filled that in. Okay, question number 8 is 11 squared, which is 11 times 11. Okay, again, from our times table knowledge, we should be able to unpick this. We should know this as 121. Last page here, then I've got 4 cubed. Now, if I cube something, I multiply it by itself and then by itself again. So 4 times 4 times 4. Again, do the first one here. I have 16, and then I'm left with 16 multiplied by 4. Okay, 16 times 4 is going to give you the answer of 64. Okay, a quick way to multiply by 4 is to times by 2 and then times by 2. Double it and double it. 16 times 2 is 32, double that is 64. And then question number 10 says circle the 2 prime numbers. So I've got 5 numbers here. I'm only going to be circling 2 of them. They both need to be prime. So what I need to spot here is the fact that these are all odd, so there's nothing easy to go and say, well, there's an even number, it's not 2, therefore it's not prime. Okay, so I can't do that straight away, but I can start looking at these and look at things that will fit in certain times tables. The ones that jump out straight away to me are these two here, because I know that they're both going to be multiples of 3, because I know that 30 and 60 are 3 times 10 and 3 times 20 respectively, and then 9 is just 3 lots of 3, so 39 is going to be 13 times 3 and 69 is going to be 23 times 3. So those ones cancel themselves out there, so actually I shouldn't be circling them because those are not those. That's not how I get to those answers there. Okay. There's one more that jumps out to me straight away, and again with strong times tables that should jump out to you as well. This 49 is a square number, so the square root of 49 is actually 7, which means that 7 squared equals 49. and because it has 7 as one of its factors, and it's not just 1 in itself, it means it can't be a prime number. So the two primes we have here are 29 and 59, which means that those numbers there only have 1 and themselves as a factor. So there's no other numbers that you can multiply together to make 29 or to make 59.